Combustion Reaction Practice Part 3. Styrene, the building blocks of polystyrene, is a hydrocarbon. Hydrocarbon, a compound consisting only of carbon and hydrogen. If 0.438 grams of styrene is burned in oxygen and produces 1.481 grams of carbon dioxide and 0.303 grams of water, what is the empirical formula of styrene? Couple of interesting things about this problem compared to about ones that we've done in the past. One, we're just dealing with the hydrocarbon, meaning only we are just looking at carbon and hydrogen. Now, there will be an overwhelming sense on your point of saying, well, let's figure out how much oxygen there is too. But notice, we're dealing with a hydrocarbon. So keep that in mind as we go through this problem. So I know that they give you a total mass. They give you the 0.438 grams of styrene. What we're going to focus on is our grams of carbon dioxide and our grams of water. So let's start off by writing our mass of carbon dioxide. So 1.481 grams of CO2. And we know the first thing that we have to do is convert to moles. So the gram formula mass of carbon dioxide is 44 grams of CO2 is equal to 1 mole of CO2. The next step is to get from 1 mole of CO2 to 1 mole of carbon, because ultimately we just want the mass of carbon. So now that we get to 1 mole of carbon, we're going to go to the mass of carbon. So 1 mole of carbon is equal to 12 grams of carbon. And if we work this out, we find that our answer is 0.4039 grams of carbon. Fantastic. Now let's look at our mass of water. Our mass of water here is 0.303 grams of water. We know that the first thing that we need to do here is convert into moles of water. So 1 mole of H2O is equal to 18 grams of H2O. Now that we're in moles of H2O, we need to get moles of hydrogen. So we know that 1 mole of H2O is equal to 2 moles of hydrogen. And again, this is very important to realize. The ratio of hydrogen to oxygen here is 2 to 1. So in every 1 mole of water, there will be 2 moles of hydrogen. And then finally, we know that 1 mole of hydrogen is equal to 1 gram of hydrogen. And if we work this out for our final answer here, we get 0.03367 grams of hydrogen. Now remember, before you even get to this step of actually doing the calculation, it is always a good idea to go back through your units and say, okay, this cancels this, moles of CO2 cancels moles of CO2, moles of carbon cancels moles of carbon, and I'm left with the mass of carbon. Same thing here. We have grams of water canceling grams of water, moles of water, moles of water, moles of hydrogen, and finally we have grams of hydrogen. Now where do we go from here? I want to take my mass of carbon, 0.4039 grams of carbon, and 0.03367 grams of hydrogen, and convert it to moles. So 12 grams of carbon is equal to 1 mole of carbon, and 1 mole of hydrogen is equal to 1 gram of hydrogen, and I want to get an answer. And when I do that, I will find that this is 0.03366 moles of carbon, and this is also around 0.03367 moles of hydrogen. Now, these are extremely close to each other. Which one's the smaller one? Well, I guess if we were getting really nitpicky, we could say this is the smaller one, and we'll divide this one by this. And ultimately, I think we can look by inspection and say that this is pretty much a 1-to-1 ratio. So what is my empirical formula here? Well, it's C1H1 because it's in a 1-to-1 ratio. Or more commonly, we just see it as CH, and that would be our empirical formula.